it is time. It's 1 p.m. here in Arizona. Apparently, most of the rest of the country and a lot of other countries too have changed their clocks today, or will be changing their clocks at some point this spring. I think that's a little silly because I live in a state that doesn't do that. But hopefully, you'll all manage to find this stream and join me, because today we're going to be making a simple infinite runner in Mini Micro, and we're going to use this to demonstrate the use of tile display and sprites, and should be a lot of fun. So let me see. I'm just going to check on Discord, make sure there's no one confused and wondering about the time. But nope, I think we're good. Okay. So you made it. Awesome. I'm glad you did. All right, so let's jump right into it. We want to make an infinite runner, and it's going to have an environment that is a tile display, and it'll be scrolling past, and our little character Kip is going to be running along at a constant speed, and when I press the space bar, he'll jump, and we want him to jump over obstacles rather than slam into them. And that's our objective for today. So where do we begin? Let's see. I think with the tile display. Let's get a tile display up and scrolling. So I'm going to bring over the Mini Micro cheat sheet. Here it is. I was cribbing from this yesterday. Yeah, that was yesterday, in order to write up the Learn X and Y Minutes tutorial content. But now we're going to use it to go look at tile display. Let me embiggen that. All right. So here are all the different properties and methods relevant to a tile display. And let's see, if I guess I should go a little bit smaller, and I can arrange this under the Mini Micro window, maybe like that. Good. All right. So let's see, we'll call our program, I've just booted, so I don't really need to reset. We'll call it runner, and we'll edit. Okay, so let's say display. We're going to have sprites. We're going to have tiles. I don't think we need any pixel graphics, so I'm going to take over display 5, which is normally pixel graphics, change its mode to display mode dot tile. Awesome. That's a very kind comment. Thank you very much. I hope you enjoyed it as much as I do. All right, and then we're going to say TD for tile display equals display 5, and then we can easily clear and reset it. Actually, if we start by clearing everything, that's usually a good policy. Now we can do td.extent. This is how big we want our map to be. And I'm picturing a map with squares that are maybe 64 pixels high. So let's see, how tall does that make the screen? 640 by, I could have done that in my head. That's 10. And then 960 divided by 64 is 15. So it's 10 by 15 tiles wide, but we wanted to go much further than that. And tile displays are cheap. It's one of the great things about them. So we'll say the extent equals, instead of 15, we'll go like 150 tiles wide and 10 tiles high. And then we'll make it scroll horizontally. I guess if I really want it to be an infinite runner, I will have to do something more clever, making the end match the beginning, and then when it gets too close to the end, I'll just jump it back to the beginning so no one will ever know. We could do that. Okay, but it's 10 screens wide. That gives us plenty of runway. So let's see. We have to set the extent. That's the size of the map. We have to set the tile set. And let's go look in pics, syspics. I will use, let's see. We have simple platform tiles. Oops, this is a nice file to use. In fact, let's view it. Syspics, that thing. And it looks like this. This is the same tile set that's used in the platform demo that comes in sysdemos. But we'll use it today because it's nice. And I think we'll just mostly use this grass and dirt tile in the top left corner. And for blocks to jump over, we'll use, I don't know, maybe one of these brick tiles or stone tiles or something like that. Will you also do a parallax effect? No pressure. Yeah, probably not today. But if we wanted to, it wouldn't be that hard. You just layer another display behind it and move it more slowly. And hi Seb, glad you could join us. All right, so this is the path that we want to use. Copy that. File.load image, that thing. All right, so we've set the extent, the tile set. We have to set the tile set tile size. So this is how big are the tiles in the tile set. So if we view this thing, the question is how big is one of these tiles? And I can actually just measure it like this. You probably can't see that because it's super tiny, but it's 64 by 64. So td.tileset tile size equals 64. Or if I wanted to specify x and y separately, I could do this. Doesn't really matter because these tiles are square. And then the size of the tiles on screen could be different if we wanted to scale these tiles up and down. I should not try to type and speak at the same time. Cell size equals 64. What was that measuring thing? Oh, that's this is just a macOS 10 feature. It's a screen capture feature. If I hit Command-Control-Shift-4, it gives me a little cursor that shows the mouse coordinates, and when I drag, it shows the size of the capture. And then it puts it on the clipboard, and I don't care about what it put on the clipboard. I was just using it for the size of the capture. Good question. Okay. Next is overlap. The cell overlap in pixels, I don't need any overlap here, so I'm not going to worry about that. Odd row offset and odd column offset. That's another thing that you don't need unless you're trying to do something like a hex display, hexagonal tile display. Then you would offset either the rows or the columns. But in our case, we don't need that. Flip-flop, yeah, that's a Mac feature. It's the built-in screen capture feature. You can capture a section, you can press the space bar and capture a window, stuff like that. Okay, what is cell overlap used for? Overlap would be used for if you had tiles that are meant to extend a little bit beyond their own rectangular area, like maybe there's little bits of grass that stick up on top, for example, then you could set the overlap to some positive value, and the cells, when they're drawn on screen, would actually overlap a bit. Or if you set the overlap to a negative value, it'll spread the tiles out and leave gaps in between, which can be useful, at least for debugging sometimes. Yeah, so that's the point of overlap. But in most cases, you don't need it, and this is one of those cases. So at this point, we have a tile display, and it's not going to show anything because we haven't set any of the tiles. It's just empty. Every tile is null. I could check that. I could say td.cell00, and it's null. So it doesn't print anything. So now we need to give it, well, here, let's just assign one. td.setCell00. We'll set it to cell 12. And here it is. This is cell 12. So how is that cell 12? Well, you have to count starting at the top, and let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is cell 12 right here. If we set it to 0, it would be this brown dirt thing. So let's do that. So it's brown dirt with grass on top. So let's actually, I have a visual aid. Let me bring this over. This is from the wiki page on tiledisplay.cell, and if you click this picture, this is a different tile set, obviously. This is another one of the tiles that is in syspix. But you can see the tiles are numbered from the top left corner in row major order, so they just go like this. So in our case, this is cell 0. If we want to get to, let's say, these gray bricks, these will be our obstacles. Yeah, that's awesome. So you can have a sheet of different tile designs and have a cell select the tile you want to display. Yep, that's exactly it. That's the big idea of a tile set. Okay, so let's find the index of this gray block here. This particular sheet has 12 per row, So this is 0, 12, 24, 36, 37, 38, 39, 40. This should be block 40. So let's try that. I'll set the cell next to it. So column 1, row 0, we're going to set it to cell 40, and boom, there we go. So 0 and 40 is what we're going to use. Let's write some code to fill out our level. So create the ground, tile 0, and then we're going to also, after that, add some obstacles. Did I spell that right? 40. Okay. The ground is easy enough for say for x in range 0 to our tile extend up here, 150. That means that we go from 0 to 149. T set cell x 0 tile 0. I feel like introducing some constants here. How about k ground tile equals 0 and k block tile equals 40. So now I don't have to say tile 0, and this doesn't have to be so mysterious. This is ground tile. Okay, let's test that. Obstacles is correct. Good, thank you. Hey, we have ground. And check this out. Actually, let's not check this out. I was going to show scrolling, but scrolling isn't going to be very easy to see until we have more interesting stuff in here. So let's add some obstacles. Let's see, how do we want to add obstacles? How about for x in range from 5 to 100 and... Actually, we'll go from 10 to 120 in steps of 13. TDS set cell x row 1, k block tile. Hey, there was a block. Thumbs up for combating magic numbers. Yeah, except that 13 I just threw in there. That's just the spacing between the blocks. It's completely arbitrary. It'll do for now. Let's get this thing scrolling, because see how easy tile displays are. Our tile display is basically done at this point. But we do need to scroll, which means we need a main loop. So our main loop is going to look like while true, do some stuff that involves yielding every frame, and then we'll just do td.scroll x equals td.scroll x plus, and this is where we decide how fast we want to scroll. This is per frame, so it shouldn't be too fast. Maybe, I don't know, 5. We'll try that. And that's it. That's all we need for a main loop. Yeah, not too bad. A little slow. Let's double that. There we go. Pretty cool. Now this is going to run out eventually, so I guess we should make it so that when it gets to the end, it starts over. Yep, there's the end. So we'll say if td.scroll x is greater than, got to do a little math here. We have 150 cells across, and they're 64 pixels wide each. And actually, we want to scroll as soon as we get within 15 of that, which would be 135. That's the point at which, if we go any further, we'll start to see the gap on the end. Yep, the edge of the world. So if our x is bigger than that, or equal, then td.scroll x equals 0. I'll just keep it simple for now. So when we get to the end, it should scroll right back to the beginning. And this will look seamless if we don't actually have any blocks in the beginning. So we won't start our obstacles until column 20. So, I have to clear the tile display, because otherwise, every time I run this, I'm going to get, first of all, it's not scrolling back, it's not starting back at 0, and it's adding more obstacles, or it should be. If I wait long enough. Yep, there's one that just appeared. All right, now we have 3 on screen. That's because clear resets all the displays to their default mode, and it clears those default displays, but this is a non-default display. This one gets hidden, but not cleared. Could mark the last tile so you can see when it loops to verify when it does for clarity. That's not a bad idea. But first let me deal with this clearing problem. After I set up the display, I want to clear it. td.clear. And let's also make sure t.scroll x starts at 0. Okay, so there we go. I'm thinking about marking the last tile, but if I sit here and rub my chin long enough, it'll become a moot point. Because there it is. You can tell from the gap where there was no obstacles that we've gone back to the beginning. All right, sweet. Tile display is done. Let's get into sprites. But maybe, since I know tile displays are new to some people, we'll just do a quick review. Make sure it really sinks in. So you start by setting the mode to display mode tile, of course. Get a handy reference to it. You want to set the extent. This is the size of your map in cells. So ours is 10 cells high and 150 cells wide. You want to set the tile set that determines the images it's drawing from and how big the tiles in that image are. So in this case, each tile is 64 by 64. Then you want to set how big they are on the screen. I'm going for the same size on screen. Clear it, reset the scroll, and that's pretty much it. Then when you want to set some cells, you use td.setCell with the XY of the cell that you want to set and which tile index you want to set it to. That's numbers like these. And then that's it. And then to make it scroll, we're just updating the scroll X, obviously. Okay, sprites. So, when it comes to sprites, especially if you're doing platformery type things, there is a library in syslib called Sprite Controllers that does a lot of the work for you. It handles updating an animation, simple jumping physics, climbing, all sorts of stuff like that. And the platform demo in SysDemos uses that. But today, since it's really about like how to use tiles and sprites at a fundamental level, I'm going to ignore this library and we're just going to do it manually. And I think that that'll be, you know, a little clearer and easier to follow what's working, what's going on. So, okay, prepare our hero. Hero is going to be a new sprite, and it needs an image. Okay, let's look in syspix again. There's this folder called KP, which stands for Kenny's Platformer, but I always just call him Kip. So let's look in syspix KP, and it has these various poses of the Kip character. We are going to have a continuous runner, so he's always going to be either running or jumping. He's never going to stand. Today, I don't think he's going to stand there and wave either. Oh, sometimes he'll be fallen. So we need these 4 sprites: fallen, jump, run 1, and run 2. And they're all in syspix KP. So edit, file.load image, syspix KP, I've already forgotten, KP-run1. Okay, we should set up the sprite display. It's set up by default when you clear. Okay, so I'm actually going to rely on that. Display 4 is always a sprite display by default. I even have a picture of that. Why can't I get you to scroll over? Because my scroll bar is way down here. But yeah. I wish I had like a, oh yeah, shift scroll wheel. Right, so display 4 is a sprite display. We're going to use that. Set up sprite display. I'm going to use SD for sprite display. I know, not the greatest variable names, but hey, it's a live stream. Display 4, sd.clear. Okay, so now we can do, having created a sprite and assigned its image, it's almost ready to be seen, but you still have to add it to a display. Because which display is it going to be on otherwise? It could be any of these 8 displays in theory. Because you can have more than one sprite display if you want. So we're going to say sd.sprites.push hero. That works because sd.sprites is a list, and we're just pushing this sprite onto the list. And as soon as we do that, we can see him peeking out of the corner down here. he's at 0, 0, and sprite position is the position of the center of the sprite. So that's why his center is down in the corner, and we can see the top right corner of the sprite image. If we want to change that, we can just say hero.x equals 480. That moves him out to the center. Hero.y equals 100. And there's Kip. And I'm just going to experimentally find, yeah, that looks like a pretty good Y position for our hero. And I think in terms of X, we don't want him in the center because that won't give you as much time to react to an obstacle. So we'll put him at maybe 280. So let's put him at 280, 110. Hero.x equals 280. Hero.y equals 110. Yeah, Seb says that's a major gotcha for most of us that the XY refers to the center of the sprite and not the bottom left. Yeah, that's interesting. I mean, there's good reason for it. And the reason is that if whatever position the XY refers to is also its pivot point. And when I want to rotate this guy, let's say here.rotation equals 90. Pay attention to where he is. I'll put my cursor right on his belly. He rotates. He should be rotating right around his belly. I guess these images are a little bit offset in the image itself. Yeah, but the big idea is that it'll rotate around the center, whereas if the position of the sprite was the lower left corner, you'd have them sort of pinwheeling around that lower left corner, which is rarely what you want. Usually rotating around the center is a lot more useful. So that's why it is. And it's the same for scaling, actually. When you scale it, no, not 300, it's 3, you want it to grow around its position and not scale away from its bottom left corner. So again, that's why the position's in the center, and if that helps you remember it, then I've done a good job, I guess. Okay, so we assign our hero, we position him at 280, 110. If we just run, there he is. Now, he's not animating yet, he's just skating along. So let's make him run. I wish so much that we had something like this in computer class when I was growing up. Yeah, me too. Hopefully, kids will be having something like this in computer classes soon. Okay, so to make him animate, we just need to change the image periodically. So I'm going to actually get this image into some other variables. So let's see. I'm going to make a frame. Load animation frames. Make a little frame map here. Frame.run1 equals, actually, I'll make this a list. Frame.run.push this. I hope so, that this is really good stuff. Oh, and Devil Dog says, I'm trying to achieve that in contact with a couple of schools about this. That would be awesome. And if there's anything I can do to support you in that, just let me know. Yeah, that would be really sweet. Okay, so we grab our 2 run frames. We're also going to grab frame.jump, which is file.loadImage kp_jump, I'm pretty sure. And frame.fall. syspix kp fall, and then we can initialize our guy to, well, we'll initialize him to the jump frame. Why not? Just to see if that's working. Yep. And let's view our other ones. View frame.run0, frame.run1. Jump we've already checked, and fall. Oop. Frame.fall did not work. All right. Where's that dir command? Fallen. It's fallen, not fall. Fallen. Okay. So view frame.fall. Yeah, that'll work. That'll be when he bashes into an obstacle. Okay. So let's see. Usually to keep things encapsulated, because in a real game you're going to have lots of sprites moving around, all doing their own things. So I find it best to give each sprite an update method, and then I'll just tell each of the sprites in my main loop to update. and the sprites are responsible for updating themselves. So FlipFlop says, it's so simple to understand as well. I feel like kids would have a great time learning. Yeah, I hope that's the case. I've really tried to make everything as simple and fun as possible. So let's have an update method. And here's where, let's see, there's two ways to do animation, at least. One is by time and the other is by counting frames. And in a simple app like this, those are going to come out to about the same thing because it's unlikely that we're going to be running at less than 60 frames per second. And this yield command here, of course, is what limits us to 60 frames per second. So I can just count frames and not have to worry about keeping track of actual wall clock time. And that's what I'm going to do today. But if you're running a game that might get bogged down and you want to make sure that things are continuing to animate and move at a consistent absolute rate, then you would want to keep track of the time and animate or move based on that instead. But today we'll do it frame based. So let's see, I'm going to have hero dot. Of course, as I say that, it's not really easier. And this is being a live stream. I want to do things the easiest way possible. So forget what I just said. I'm going to do it by time. So I'll say next frame time. And this is going to be the time at which we should change frames. So in our update function, we can say if time is greater than self.nextFrameTime, then this is when we need to move to the next frame. And I should have hero.curveFrame. That's the current frame, 0 or 1. So to change it, we can just do hero.curveFrame equals, I could say not hero.curveFrame. Or if you want it to be more general, to having more than just 2 frames, we could say hero.curveFrame plus 1 mod self.run.length, which is the number of frames in our run animation. And then, let's see, self.image equals frame.run hero. Why am I saying hero here? It's supposed to be self. I mean, it would work either way as long as we only have one hero, but we may have more heroes someday, you never know. Self.curveFrame. Okay, so we update our curveFrame number. This is the frame index. And then we update our image. This is what the sprite actually displays. And we want to set our time, self.nextFrameTime, was time plus some small increment. So 0.1 would have them changing frames 10 times per second. That might work, but it doesn't because I'm not calling my update method. So let's see, yield, scroll the screen, also update the hero. I find that this brings things back to a more basic level where you need to do a bit more thinking because it makes you understand how things work under the hood. So many game engines wrap what you're doing so much, it seems. Yeah, yeah, that's true. And that's why we're not using the platform or the sprite controllers library, because that gives you a lot more functionality out of the box, but it does kind of hide what's going on. Every Sonic needs a tail, so maybe more than one hero. Yeah, maybe. Key not found, run not found in map line 48. What you talking about, line 48? Self.run.len. It's not self.run, it's frame.run. Yep. Hey, there he is. Run, run, run. That's good fun. All right, now let's make him jump when we press the space bar. Okay, so we need to know when he's jumping. And we're going to need to know his y velocity. Actually, if we knew his y velocity, that would suffice. I'm pretty sure. His y velocity and his y position. So he's adorable. Yeah, he's pretty cute, isn't he? All right. So let's give him a vy, which is velocity y property, which is initially 0. This is going to be how many pixels he moves up per frame. And whenever he's doing that, he's going to be in the jump pose. So how does he get into the jump pose? Maybe we should check for that first. if key.available and key.get is equal to spacebar, then we'll just do the jump code right here, actually. Jump. And how do we jump? Oh, we should only do this if we're not already jumping, but we'll come back to that. We're going to jump just by doing self.image equals frame.jump, self.vy equals some big number that makes them go up, like 20. And I think that's it. Then, when we're jumping, if self.vy is not equal to 0, or, actually, here's a more direct way to tell if we're jumping. Lots of ways we could do this, but if self.image is equal to frame.jump, then continue jumping. And we do that by doing self.y equals self.y plus self.vy. That makes them go up. And then to apply gravity, we just want to reduce this vy by a little bit every frame. So self.vy equals self.vy minus, I don't know, 2. Look at me making stuff up as I go along. And that should make him go up and then come back down, and he'll shoot right through the floor. But let's test that much at first. Well, that is not what I expected. Because we're continuing to do the run. And since we tell when we're jumping by looking at the frame, that immediately stops the jump. Yeah, he jumps too well. Our guy flies. So I really want to say else, continue running. Okay, whoop. And there he goes. Wow, why did he do that? He did that because I foolishly initialized his frame to the jump animation. Let's instead do frame.run 0. Okay, there he is. He's running until I press the space bar, and then he jumps right off the screen. That was pretty awesome. Good sized jump too. All right, so now we need to make him stop jumping, and we can do that by saying if self.y is less than or equal to, not 0, k ground level, which is a constant that I'll define in a moment, then stop jumping. Self.image equals frame.run 0, self.y equals k ground level, and vy won't matter anymore, but we'll go ahead and reset it to 0. That should work if we had a k ground level, which we would use right here. It's 110. Where do we put this magic number? We'll put it up here with the other magic numbers. Okay. Boing, boing. Hey, there we go. Nice. This is fun. All right. He can do that though. Makes it pretty easy. In fact, I could play Flappy Bird. I have Flappy Kip here right now. And that's because, of course, I'm allowing my character to jump when he's not grounded. So, let's change that. This checking for the jump should only happen if we're running. So we'll do it here. Okay. Oh. Maybe I shouldn't be using key available, or yeah. Because what's happening is those key presses are buffering up in the keyboard buffer, and key.get draws from the keyboard buffer. So how do we want to fix that? One way is I could put this back to the top of the loop, go ahead and get the key, but only jump if we're in the running state. Yeah, I think I like that best. The other way is, instead of using key available, I could watch the key state with key.pressed, but I'm just going to change this to jump if we are currently grounded. If self.image is not equal to frame.jump, then jump. Can you clear the buffer? You can, yeah. You just do key.clear. And I briefly thought about that, but I couldn't think of a good place to put it. So I think this will work nicely though. So, yep, I can hit the key several times, and unless I press it after he's already on the ground, we only get one jump. So, perfect. All right, boink. We're gonna need some sound effects at some point. But first, let's see if we can get him bashing into the wall, which will be the first time that we've actually done collision checking between the sprite and the tile display. So that'll be kind of fun. How do we do that? Well, we have to just do a little bit of math to figure out where is the cell right in front of Kip. So I'm going to make this a separate method. Check collision, if I can spell. Self.check collision. All right. So hero.check collision equals a function. So far, so good. The tile display is scrolling. Our sprite display is not. Of course, there's a lot of different ways you could do this. We could scroll the sprite display, but that doesn't really help in this case. So we just got to take the scrolling into account. If this display was not scrolled, our cell x would be self.x divided by 64, which is the extent. I could even say td.cell size if I wanted to get the magic number out of there. So let's do that. So td.cell size. If we weren't scrolled. If we are scrolled, we have to add some to our x position. So self.x plus the scroll divided by the cell size. That should do it. Then we can say if td dot, let's bring back our cheat sheet. Cell xy, td.cell xy is equal to k obstacle, then we've collided. Well, that's true only if our y is low enough that we would actually hit it. Let's see, the y is the center of the block, so how picky do we want to be? Let's say if our center is, here we'll do this. If self.y is greater than td.cell size times 2, that would mean the center is higher than, I'm getting myself all tangled up here. Hero.y, 110. Cell size is 64. Let's move our hero up until we think he's high enough. Nope. Watch out for xy and td.cell. Yeah, okay, thank you for that. I will check that when we get back to it. That's a little too high, I think. Okay, we're going to do this experimentally. We're going to say if he's over 170 pixels, then he clears the block. I think that'll work. So if self.y is greater than 170, then return, jumping, therefore no collision. Otherwise, we hit something. And for now, we're just going to print ouch and exit. Undefined identifier y. Oh, is that what you were just telling me? Yep. Cell x. And what cell y? I want to look at the row 1, right where we prepared our obstacles, right here. Good catch, Seb. Thank you. Okay. So, undefined identifier k obstacle. Well, I defined a constant and then I didn't use it. Okay, block tile. Okay. Boink. Ah, ouch. Let's see if I can do better. Hey, I can. Nice. The other thing I'm kind of tempted to do, though, is if you come down on it, that shouldn't count. So if I do that, I feel like I should have got away with that because I'm coming down. So if our self.y is greater than 170 or self.vy is less than 0, which means we're coming down, then return. Right, the trouble is I came down, got all the way to the ground, and I'm still on that block. In fact, should I be rounding or flooring? I'm not doing either one, so by default it's equivalent to flooring. Until you add spikes to some blocks. Yeah, that would be fun. In fact, I think this tile set has some like that, but we're not going to get to that today. Let me run again and see how picky this is. That was okay. That is not okay. Well, anyways, I don't want to spend too much time on this. You can imagine, I hope, how you could tweak this collision function to make it as permissive or as strict as you want to be. So, although come to think of it, my basic demo is pretty much done at this point. But it needs some sound effects. Yeah, this is fun, isn't it? Sound effects would make it more fun, so let's take a peek in our sounds folder. I know it wasn't going to be a sounds demo today, but it's been way too quiet. So sys sounds. Oh, there's a hit sound that I think would be perfect. Let's use view sys sounds hit.wave. Oh yeah, that's loud. I'll probably turn the volume down on that a little bit. So with sounds, I like to preload them at the top, near the top of the program. Load sounds, hit sound, equals file.load sound. Sys sounds, hit.wave. And then we need a jump sound too, no doubt about it. I don't know if there's a good jump sound in the digitized sounds. Oops. You make a typo and it goes bam at you. Bongo might not be a bad jump sound. But the other thing we could do is load or import sounds. Yeah. In fact, let's do sounds.demo. So that's a pretty good sound. There's also a landing sound. So we'll use these when he jumps. So sound.bounce and sound.land. And you can run these, I think, by doing sound.bounce, which is a sound. Nope. Sounds.bounce, which is a sound, and then just play. Okay, and that's a little bit loud. We'll probably play it at a lower volume, so 0.5. Yeah, 0.2 is plenty for that, I think. All right, let's do it. So, what did I say? Import sounds. I'm not importing anything yet, but now I am. When we jump, let's see, jump, sounds.bounce.play, 0.2, continue jumping, stop jumping, i.e. land. We're going to do sounds.land.play. Was it called land? No, I've forgotten. No, it was called fall. Sounds.fall.play. What's robo what? FlebFlob wants to know. Yeah. And today, Ida learned Vue works on sounds. It does. Okay. Sounds.demo. Inquiring minds want to know, what is robo what? That's robo what. What? And here's a sad robot. Oh. And there's a uh-oh. Yeah, there's all sorts of weird sounds in there. Play with the demos and the libs. Good stuff. Okay. Sounds fall play, sounds bounce play, and when we hit something, we want to play, what did I call it? Hit sound. Ouch. Hit sound.play. Those make good power up and down, power down sounds. Yeah, they could. All right. Okay, fall was not the one that I thought I was getting. I did want land after all. Yeah. Land. Not fall. There we go. Nice. I really need to make some of these obstacles like closer together to make it more challenging because this is too easy. Yep, pew pew. All right, I'm gonna, boof. It's very satisfying. I'm gonna add some more obstacles to make this a little more challenging. And what we'll do is we will use the power of prime numbers. So here we're adding blocks in multiples of 13. Let's add some more blocks in multiples of 17. Yeah. That should be interesting. Oh, didn't make it. That gets hard fast. No, I don't need to edit. I just need to try harder. There we go. Oh, double. Nice. Oh, this is good fun. All right. I'm gonna quit playing. We'll let poor Kip run into a wall. There he goes. All right. Boof. Yeah, for sure. I'm gonna throw this up on GitHub, I guess, or maybe I'll post it to the forums. Actually, I think forums would be better for this because it's only like 108 lines long. There's really not that much to it. But you can take this and run with it and jump with it. See what I did there? Yeah, I cracked myself up. And look at me, done 12 minutes early. That's unusual. Anybody have any questions? Anything else you'd like to see before we call it quits for the day? I see I have to wait because the stream chat is actually quite slow. There's a significant delay between when you type something and when it shows up for me. I suggest to make a gist and post it on the forums Discord. Yeah. Do it again. Yeah, sorry, Devil Dog. Can't do that, but you can go back and watch the stream video for a couple of weeks. And if I would get off my duff and pull it down and post it on YouTube, you could watch it forever. So yeah, we'll see if I get the ambition to do that. But you can at least watch it for a couple of weeks. And making a gist is a good idea. I'll look into that. Although, I mean, I can also just post the code directly on the forums because it's not that long. But maybe it's easier for you if I make a gist. Maybe easier to copy or something like that. So I'll take a look at that. Right. In the meantime, thanks everyone for stopping by and joining me on this. This was a lot of fun. I hope you enjoyed it as much as I did. And I'll see you next time. Till then, happy coding.